Hi kids, welcome back to Common Core Algebra II. Today's notes are on 9.2 complex numbers. All numbers fall into a very broad category known as complex numbers. Complex numbers can always be thought of as a combination of real number with an imaginary number, and it will have the form a plus bi, where a and b are real numbers. We say that a is the real part of the number and the bi is the imaginary part of the number. These two parts, the real and the imaginary, are not considered like terms and cannot be combined. Like real numbers, complex numbers may be added and subtracted, multiplied and divided as well. All right, the key to these operations is that the real components can combine with the real components and the imaginary with the imaginary components. All right, so as we work on these, hopefully you'll see that they're not so bad. We introduced in the last lesson what I is, and I is our imaginary number, the square root of -1. So here we have to find each of the following sums and differences. So simply, we're just going to make sure that we combine the like terms. So I'm going to get rid of the parentheses first. So -2 plus 7i plus 6 plus 2i. So we have no negative sign here. This is a positive, a plus sign. So we can just remove the parentheses, and now we just combine like terms. So we're going to combine our -2 and our positive 6 to get a positive 4. And then we're going to multiply our positive 7i and our positive 2i to get positive 9i. Okay, not so bad. So why don't you take a few minutes and do the other three in this set, because I don't think you're going to need much help from me to do this. Okay? So hopefully on this one you got 20 plus 3i. On this one you had to take one extra step because we have this negative sign right here, and we know that when we distribute that negative sign, this becomes -2 plus 7i. So when we combine like terms, we get 3 plus 10i. And this last one, we have to do the same step here. So we're going to do -3 plus 5i plus 8 minus 2i. And I never skip that step because it's just so important and it's so easy to make a mistake if you remember to distribute that first, that negative sign. So once again, we're going to combine like terms. The -3 and the positive 8 is 5, and then the 5i and the -2i is plus 3i. I'd like to say any questions, but unfortunately I can't hear you. So hopefully you understand what we just did, and we're going to move on to exercise 2, which is simply a multiple choice question. And it says, which of the following represents the sum of these two numbers? Now, the important word to make sure that you're understanding the meaning of is the word sum, which we hopefully know is adding. It's the result when we add two things together. So in this case, because we're adding, and this is going to be a plus sign here, we can just combine our like terms and get -2, combine our imaginary terms and get -3i, and see our answer is right here. So adding and subtracting complex numbers is straightforward because the process is similar to combining algebraic expressions that have like terms. The complex numbers are closed under addition and subtraction. So i.e. means in other words. So in other words, when you add or subtract two complex numbers, the result is still a complex number, okay? But is multiplication closed? So let's see what happens there. Exercise 3. So now this is going to work something like double distributive when we multiply two binomials. So you could, some people use that acronym FOIL to help us remember the steps, but you're basically distributing the first binomial to the second binomial. So it's going to be 3 times 7 is 21. 3 times 2i is positive 6i. And just like when we multiply two binomials, you can also stack these, so it's a little bit easier to combine the like terms. So when we multiply these two, we get positive 35i. And lastly, we get positive 5 times positive 2, which is positive 10i squared. All right, so now we're going to combine like terms, and we get 21 plus 41i. Now be careful here. This is plus 10, and if we remember, I squared is negative 1. So I get 21 minus 10, that's from here, plus 41i. So I get 11 plus 41i. Sorry, just reset, as my final answer. All right, so this step here where we multiplied, sometimes you might be able to go directly to that. Because when you notice that you have an I squared, you just negate the coefficient in front of it. And sometimes that makes it a little bit easier to combine like terms. So let's do B. If you're feeling good about this, pause it and do it on your own, and then come back to us. So first terms, negative 2 times 3 is negative 6. Outside terms, negative 2 times negative 2i is a positive 4i. Inside terms is a positive 18i. And last terms, it's going to be a negative 12i squared. Now, this is what I'm saying. I'm going to write that because I don't want to skip steps too soon. But some people might be able to write that automatically as a positive 12. Okay, but it's okay to do as many steps as you need to keep it straight in your head. So you get negative 6 plus 22i, but this becomes now negative 12 times negative 1. And hopefully you're realizing that this always becomes a real portion that we're going to add to our first part here. So we're going to get negative 6 plus 12 plus 22i. So that's going to be positive 6 plus 22i as our final answer. Moving on to our last problem. Is this one? Okay, so again, 4 times 5, negative 20. Positive 4 times negative 3i is negative 12i. I times negative 5 is negative 5i. Notice how we always put the I in the back just like a variable? And positive I times negative 3i is negative 3i squared. So we're going to add our like terms. We get negative 20 minus 17i minus 3i squared. So it's negative 20 minus 17i minus 3 times negative 1. Now here I did one extra step, so no worries about that. So I get negative 20, that's this one. That's a negative 3 times a negative 1, hopefully you're telling me plus 3, minus 17i. Combine like terms here, minus 17 minus 17i is going to be my final answer. So as of right now, my answer is going to be, yes, this does appear to be closed. That when I multiply 2, I do tend to get a complex number back again. All right? So now, let's go on to exercise 4, which is a little bit more complicated, but it's still using all of the processes that we just learned about. All right, so write down what you need to before meeting me at exercise 4. So exercise 4 says, determine the results of the calculation below in simplest a plus bi form. Okay, so we're going to just take it step by step. So on the left side, we have a double distributive, and on the right side, we have a single distributive. This isn't so bad. So let's do what we know. So we're going to multiply this times this, and we get negative 15 And outside terms is going to be positive 5i. And inside terms, negative 6i. And the last terms are plus 2i squared. All right? So on this side, the left side of the plus sign, I have minus 15 minus 1i plus 2 times, and I'm going to say negative 1 right away. So what do I have here? I have negative 15 minus 2 minus I, which is negative 16 minus I. Now, some people don't like working that way, all the way down on the left-hand side, but sometimes I find it a little bit easier. So you could, at this point, now start saying to yourself, now we're going to do that big old plus sign here, and we're going to get 4i, and let's write it out so we don't get confused. So we're going to do this part next. So multiply distributed, and you get positive 8i plus 12i squared, which is plus 8i plus 12 times negative 1. So what am I adding to this? So basically at this point now, I have negative 17 minus I. And on this side, I guess I should take this one step further and say this is 8i minus 12, or minus 12 plus 8i. So I'm going to add that. I'm going to add those like terms together. And our final answer is going to be minus 29 plus 7i. So if it confused you the way that I did that, kind of staying on the left-hand side, you could have absolutely worked your way the other way. You could have started with the negative 15 plus 5i minus 6i plus 2i squared, and keep going, plus 8i plus 12i squared. And then basically at that point, just combine like terms. All right, so if that was confusing for you, you can absolutely take this route as well. You'll get to the same answer. Okay, we have one more example to do, and that's it for today. So which of the following products would be a purely real number? So, do we have to consider all of these? And I think we can probably use a little common sense here and say, when we do the first term, we're going to get a real number. And when we do the last term, we get a real number. It's those inside and outside terms that give us the imaginary number. So in this case, I'm going to get 6i here, and I'm going to get minus 4i here. So that is not going to give me a completely real number. All right, and similarly, it's going to be the same for 2 and 4. What we're going to recognize is that when we have conjugate pairs, remember what a conjugate pair is? When it has the first term and the last terms being the same with different signs, positive and negative in the middle. When we take a look at this one, so for example, let's take a look at our number 3 solution, which is the correct one. And now we're going to apply what we know about multiplying binomials. We get 25 minus 2i, not minus 2i, minus 10i, I forgot to multiply, all right, plus 10i minus 4i squared. So if you notice right here, our middle terms, which are going to be our imaginary portion, cancel out, just like they do with the difference of two perfect squares. So what we're going to end up here with is 25 plus 4, because I'm going to remind you this is negative 4 times negative 1, which changes my sign to positive 4, which gives me a purely real number. Okay, so that's what I want you to take away from this. Maybe you can make a little note over here about conjugate pairs. And I'm sorry, I just spelled it wrong. This is a U. Conjugate pairs. All right, so make a little note to yourself as to that middle number canceling out and just getting a purely real number as a solution once you multiply them. All right. So kept it at 15 minutes today. Hope that was good for you. And until next time, always make good choices.